Hello all. In today's lecture, we are going to see about half subtractor. What is a half subtractor? Half subtractor is nothing but a normal arithmetic subtractor, but it does the subtraction of two input binary numbers. And then it will give you two output, one is your borrow, another is your difference. This half subtractor is again an example for a combinational logic circuit. Clear? What is a half subtractor? Half subtractor, it is nothing but an arithmetic subtractor which does the subtraction of two input binary bits. So how many input? Two input. Clear? And it will give me two output. What are the outputs? One is my difference. The other is my borrow. Clear? This half subtractor is again an example for your combinational logic circuit. Clear what a half subtractor is? Now let's see how to design a half subtractor using combinational logic circuit. Whenever it comes to designing any circuit, what are the four basic steps that you have to consider in designing a combinational logic circuit? Always remember, whenever a question is being asked to you to design, what are the basic steps? Your first step has to be, you have to draw the block diagram, and from the block diagram you have to draw the truth table. And from the output of your truth table, you have to find the Boolean expression. For that, you need K-map. Then, after finding the Boolean expression from the K-map, your final step is designing using logic gates. These four steps are very important. These four steps are the basic steps to any design procedure. Whenever they are asking you to design a half adder, be it a half adder, or be it a full adder, or be it a half subtractor, or be it full subtractor, whatever might be the circuit, if they are asking you to design using combinational logic circuit, all these four steps has to be there in your output. Clear? Now, let's see how to design a half subtractor. So, what is the first step? You have to draw the block diagram. Let's see how to draw the block diagram. This is my half subtractor. So, how many inputs are there in a half subtractor? It has got only two inputs. I am assuming my input as A and B. Clear? Now, how many output does this half subtractor has? It has got two output. One is my difference, another is my borrow. Clear? Now, after drawing the block diagram, what is the next step? I have to draw the truth table. For a truth table. Clear? What are my inputs? A and B are my inputs. And what are my outputs? Difference and borrow. Clear? How many inputs are there? I've got two inputs. So how many combinations will I be getting? If the number of inputs are 2, how many combinations? That is n is equal to 2. So the number of combinations is, how do you find? For the number of combinations is 2 power n, which is 2 power 2. This is equal to 4 combinations I'll be getting. That is, it varies from 0 to 3. Clear? Can we give the combinations in binary numbers here? It is 0, 0, 0, 1, 1, 0 and 1, 1. Let me give the decimal number also. Clear? I've got my inputs here. What is the next step? You have to find out your output. How do I find my output? 0 minus 0. This is my A and this is my B. Now I have to find my difference and I have to find my borrow as well. Clear? 0 minus 0. What is it? Output is 0. I don't have any borrow, so my output is 0. Clear? Now, 0 minus 1. 0 minus 1. This is something like A equal to 0 and B equal to 1. Can I do a subtraction here? No. So, what I have to do? I have to borrow a number. So, I'll be borrowing a number from a previous number. So, this number will become 10. So, 10 minus 1, it is 1. This is my difference. And since I have done a borrow, my borrow will be 1. Whenever you do a borrow, then you have to mention 1 for your borrow. If you are not borrowing any number, then your borrow output will be 0. Is it clear? Since I have borrowed here for doing the subtraction, so my borrow will be 1. If I am not borrowing any number, my borrow will be 0. Clear? So what is the output? Difference is 1 and my borrow is 1. Is it clear? Now, my next combination, 1 and 0. So my A is 1 and B is 0. When your A equal to 1, B equal to 0, can you do a subtraction? Directly we can do it. So 1 minus 0, it is 1. Am I doing any borrow here? No. So my borrow output will be 0 and this is going to be my difference. Difference output is 1. Is it clear? So difference is 1 and my borrow is 0 since I have not done any borrow. Clear? Now, What is your last combination? It is 1 and 1. So when my A equal to 1, B equal to 1, do the subtraction of it. 1 minus 1, it is 0. I'm not doing any borrow, so my borrow will be 0. Clear? And what is my difference? 1 minus 1, it is 0. So difference is 0. Clear? So my output is 0. Is it clear? Now I've got my output in my truth table. What is your next step? You have to find the Boolean expression for your output. But how do you find the Boolean expression? You have to take your output to your K-map, simplify it, and then you'll be getting your Boolean expression. Clear? Now, how many outputs you have? You have got 2 outputs. So, how many K-maps are required? You require 2 K-map. Let's do the K-map part here. You have to draw a K-map for difference separately and as well as for borrow separately. So, you need 2 K-map. One is for difference, another is for borrow. So, how many variable K-map you will be drawing? How many inputs you have? You have got only 2 inputs. So, how many variable K-map you will be drawing? 2 variable K-map. Based on your inputs, if your input is 2, you will be taking 2 variable K-map. In case if your input is 3, then you will be going for 3 variable K-map. If your input is 4, you will be going for 4 variable K-map. Is it clear? Based on number of inputs that you have to decide on which K-map you have to select. Clear? Now, this is for my difference. In a similar way, you have to draw the K-map for your borrow as well. This is for my borrow. Clear? Now, I have drawn the K-map for difference separately and for borrow separately. What is the next step? You have to position the values in your K-map. How do you position? For that, let's take difference alone for now. Clear? On your difference column, you have to check on your output where all you have got 1. Wherever you have got 1 on your output, check for the corresponding decimal number. And against that particular decimal number, which has got an output of 1, on that particular decimal number, you have to position 1 in your K-map. By default, you are going to assume only SOP. Is it clear? Now, for the difference, where all have you got 1? You have got a 1 here, you have got a 1 here. Check for the corresponding decimal number. It is 1 and 2. So, against 1 and against 2, I'll position 1. Clear? Now, try to do the mapping. Can we do any grouping here? No, we have to go only for single variable mapping. Right? You very well know by default in SOP, we consider 0 as a complement of that particular variable and 1 as your actual variable. Now, all the digits on your vertical corresponds to the letter A and the digits on your horizontal corresponds to the letter B. Now, since 0 is represented as a complement of that particular variable, we are going to mention 0 as A bar and 1 it will be mentioned as A. Similarly, for the horizontal part, here we have got 0 and all the horizontal part corresponds to the variable B. Since it is 0, we are going to represent it as B bar and here, since it is 1, we are going to represent it as B. Clear? Now, try to give the equation. For difference, what is your equation? It is, for this particular bubble, it is A, B bar plus, for this particular bubble, on your vertical it is A bar and on your horizontal it is B. How many minterms you will be getting is dependent on how many bubbles you have in your K-map. We have got only 2 bubbles here, so we have got only 2 minterms. Clear? And since it is a single variable mapping, whatever elements are there in the vertical and on the horizontal for that particular bubble, we are going to use that for framing the minterm. This is only for the case of single variable mapping. In case, if there is a grouping of a pair or a quad or an octave, there in that particular case, all the common terms will be taken for a minterm. Is that clear? Fine. Now, what is this expression representing? Which gate is it representing? This is my XOR gate. So, how do you represent your XOR gate? This is represented like this. So, what does it mean? Your difference is the XOR combination of your input. Is it clear? We have got 2 inputs here, A and B. The XOR combination of these 2 inputs is going to give me difference. Is it clear? Now, we are done with finding the expression for your difference. In a similar way, we have to find the expression for borrow as well. Clear? For the borrow, check on your output. Wherever you have got 1 on your output, check for the corresponding decimal number and against that particular decimal number, you have to position 1 in your K-map. Clear? Now, for the borrow, where you have got 1, you have got 1 only in one position. So, check for the corresponding decimal number, it is 1. So, against 1, you have to position 1. You don't have 1 in any other place. You have got 1 only in this particular place. Right? Now do the mapping. It is a single variable mapping. So give me the expression. This is A bar, this is A, this is B bar, and this is B. So my borrow is, for this particular bubble, it is A bar and B. I have to consider whatever term is there in my horizontal as well as on the vertical. Clear? For that particular bubble. For this particular bubble, on your vertical it is A bar and on your horizontal it is B. So both have to include it. Clear how to find out the expression for the borrow and difference? This is the final Boolean expression for my difference and borrow. Now we have done with the true table, we have done the K-map, and then we have found the Boolean expression as well. So what is the final step? You have to design them using logic gates. So let's do the designing part. Now for designing, how many inputs I have? I've got only 2 inputs, A and B. So let me take both my inputs. This is A and this is B. What is my difference? Output difference is nothing but my XOR combination of my inputs. Right? So A and B, XOR combination of A and B is going to be my difference. What is this? This is nothing but A XOR B. Is it clear? So we have designed the circuit only for difference. We have to design it for borrow as well now. What is the borrow output? Borrow output is nothing but A bar into B. A bar. What do you mean by A bar? A bar is nothing but the complement of A. Right? So A, I already have it here. Take A from here and then I'm going to complement it. How do I complement? By passing it inside a NOT gate or an inverter gate. After passing it inside a NOT gate, the output of this particular NOT gate will become A bar now. Clear? Now I've got my A bar. With A bar, what I have to do? I have to do a product of B. So this is my B output. I have taken B from here. So this is my B output. So B and A bar, I have to do a product. So this is A bar B. Clear? This is nothing but my borrow output. This is how you will be designing your half adder using combinational logic circuit. Understood how to design a half adder using combinational logic circuit? Let's sum it up. In today's lecture, we saw what a half adder is and how to design a half adder using combinational logic circuit. What is a half adder? Half adder is nothing but a normal arithmetic subtractor with 2 input binary bits and 2 outputs. And what are my outputs? One is my difference, another is my borrow. And this half adder is again an example for a combinational logic circuit. Clear? Now, after that, what did we do? We tried to design this half adder using combinational logic circuit. For designing, what are the 4 basic steps that is required? First, you have to draw the block diagram. We have drawn the block diagram here. And after drawing the block diagram, you have to derive your truth table based on your inputs. Now, depending on the number of combinations, you can decide on what your output has to be. Clear? Now, after finding the output, what is the next step? You have to find the Boolean expression. But how do you find a Boolean expression from a truth table output? For that, you have to take the output of your truth table to your K-map, do the positioning and then do the mapping, try to get the simplified Boolean expression. And after finding the final simplified Boolean expression for both your outputs, what is the next step? You have to design them using your logic gate. Clear? And this is the final design of your half adder using combinational logic circuit. I hope you are clear with this lecture. If you find my lecture useful and informative, please do like, share and subscribe to my channel. Thank you.